Demersal fish live and feed on or near the bottom of seas or lakes. They occupy the sea floors and lake beds, which usually consist of mud, sand, gravel or rocks. In coastal waters they are found on or near the continental shelf, and in deep waters they are found on or near the continental slope or along the continental rise. They are not generally found in the deepest waters, such as abyssal depths or on the abyssal plain, but they can be found around seamounts and islands. The word demersal comes from the Latin demerger, which means to sink. Demersal fish are bottom feeders. They can be contrasted with pelagic fish which live and feed away from the bottom in the open water column. Demersal fish fillets contain little fish oil, whereas pelagic fish can contain up to 30%. Types. Demersal fish can be divided into two main types: strictly benthic fish which can rest on the sea floor, and benthopelagic fish which can float in the water column just above the sea floor. Benthopelagic fish have neutral buoyancy, so they can float at depth without much effort, while strictly benthic fish are more dense, with negative buoyancy, so they can lie on the bottom without any effort. Most demersal fish are benthopelagic. As with other bottom feeders, a mechanism to deal with substrate is often necessary. With demersal fish, the sand is usually pumped out of the mouth through the gill slit. Most demersal fish exhibit a flat ventral region so as to more easily rest their body on the substrate. The exception may be the flatfish, which are laterally depressed but lie on the sides. Also, many exhibit what is termed an inferior mouth, which means that the mouth is pointed downwards. This is beneficial as the food is often going to be below them in the substrate. Those bottom feeders with upward pointing mouths, such as stargazers, tend to seize swimming prey. Benthic fish. Benthic fish, sometimes called ground fish, are denser than water, so they can rest on the sea floor. They either lie in wait as ambush predators, maybe covering themselves with sand or otherwise camouflaging themselves, or move actively over the bottom in search for food. Benthic fish which can bury themselves include dragonids, flatfish and stingrays. Flatfish are an order of ray-finned benthic fishes which lie flat on the ocean floor. Examples are flounder, sole, turbot, plaice, and halibut. The adult fish of many species have both eyes on one side of the head. When the fish hatches, one eye is located on each side of its head, but as the fish grows from the larval stage, one eye migrates to the other side of the body as a process of metamorphosis. The flatfish then changes its habits, and camouflages itself by lying on the bottom of the ocean floor with both eyes facing upwards. The side on which the eye migrates depends on the species, so some species end up with both eyes on the left side, and others on the right. Flounder ambush the prey, feeding at soft muddy area of the sea bottom, near bridge piles, docks, artificial and coral reefs. The diet consists mainly of fish spawn, crustaceans, polychaetes and small fish. The great hammerhead swings its head in broad angles over the seafloor to pick up the electrical signatures of stingrays buried in the sand. It then uses its hammer to pin down the stingray. Some fishes don't fit into the above classification. For example, the family of nearly blind spider fishes, common and widely distributed, feed on benthopelagic zooplankton, yet they are strictly benthic fish, since they stay in contact with the bottom. The fins have long rays they use to stand on the bottom while they face the current and grab zooplankton as it passes by. The bodies of benthic fish are adapted for ongoing contact with the sea floor. Swim bladders are usually absent or reduced, and the bodies are usually flattened in one way or another. Following Moylan check, they can be divided into 5 overlapping body shapes. Benthopelagic fish inhabit the water just above the bottom, feeding on benthos and zooplankton. Most demersal fish are benthopelagic. Deep-sea benthopelagic teleosts all have swim bladders. The dominant species, roughtails and cusk-eels, have considerable biomass. Other species include deep-sea cods, deep-sea eels, halosaurs and notocanths. Benthopelagic sharks, like the deep-sea squaloid sharks, achieve neutral buoyancy with the use of large oil-filled livers. Sharks adapt well to fairly high pressures. They can often be found on slopes down to about 2,000 meters, scavenging on food falls such as dead whales. However, the energy demands of sharks are high, since they need to swim constantly and maintain a large amount of oil for buoyancy. These energy needs cannot be met in the extreme oligotrophic conditions that occur at great depths. Shallow water stingrays are benthic, and can lie on the bottom because of the negative buoyancy. Deep-sea stingrays are benthopelagic, and like the squaloids have very large livers which give them neutral buoyancy. Benthopelagic fish can be divided into flabby or robust body types. Flabby benthopelagic fishes are like bathopelagic fishes. They have a reduced body mass and low metabolic rates, expending minimal energy as they lie in wait to ambush prey. An example of a flabby fish is the Cuskelacanthona salmatis, a predator with a huge head and a body that is 90% water. This fish has the largest ears and the smallest brain in relation to its body size of all known vertebrates. Deepwater benthopelagic fish are robust, muscular swimmers that actively cruise the bottom searching for prey. They often live around features, such as seamounts, which have strong currents. Commercial examples are the orange roughy and Patagonian toothfish. Habitats. The edge of the continental shelf marks the boundary where the shelf gives way to, and then gradually drops into abyssal depths. This edge marks the boundary between coastal, relatively shallow, benthic habitats, and the deep benthic habitats. Coastal demersal fishes live on the bottom of inshore waters, such as bays and estuaries, and further out, on the floor of the continental shelf. Deep water demersal fish live beyond this edge, mostly down the continental slopes and along the continental rises which drop to the abyssal plains. This is the continental margin, constituting about 28% of the total oceanic area. Other deep-sea demersal fish can also be found around seamounts and islands. The term bathydemersal fish is sometimes used instead of deep-water demersal fish. Bathydemersal refers to demersal fish which live at depths greater than 200 meters. The term epibenthic is also used to refer to organisms that live on top of the ocean floor, as opposed to those that burrow into the seafloor substrate. However, the terms mesodemersal, epidemersal, mesobenthic and bathybenthic are not used. Coastal demersal fish are found on or near the seabed of coastal waters between the shoreline and the edge of the continental shelf, where the shelf drops into the deep ocean. Since the continental shelf is generally less than 200 meters deep, this means that coastal waters are generally epipelagic. The term includes demersal reef fish and demersal fish that inhabit estuaries, inlets and bays. Young mangrove jacks, a sought-after eating and sport fish, dwell in estuaries around mangrove roots, fallen trees, rock walls, and any other snag areas where smaller prey reside for protection. When they mature, they migrate into open waters, sometimes hundreds of kilometers from the coast to spawn. Stargazers are found worldwide in shallow waters. They have eyes on top of the heads and a large upward-facing mouth. They bury themselves in sand, and leap upwards to ambush benthopelagic fish and invertebrates that pass overhead. Some species have a worm-shaped oar growing out of the floor of the mouth, which they wiggle to attract prey. Stargazers are venomous and can deliver electric shocks. They have been called the meanest things in creation. Other examples of coastal demersal fish are cod, plaice, monkfish and sole. Deep water demersal fish occupy the benthic regions beyond the continental margins. On the continental slope, demersal fishes are common. They are more diverse than coastal demersal fish, since there is more habitat diversity. Further out of the abyssal plains, these flat, featureless regions occupy about 40% of the ocean floor. They are covered with sediment but largely devoid of benthic life. Deep-sea benthic fishes are more likely to associate with canyons or rock outcroppings among the plains, where invertebrate communities are established. Undersea mountains can intercept deep-sea currents and cause productive upwellings which support benthic fish. Undersea mountain ranges can separate underwater regions into different ecosystems. Routails and brotulas are common, and other well-established families are eels, eelpouts, hagfishes, greeneyes, batfishes and lumpfishes. The bodies of deep-water demersal fishes are muscular with well-developed organs. In this way they are closer to mesopelagic fishes than bathypelagic fishes. In other ways, they are more variable. Photophores are usually absent. Eyes and swim bladders range from absent to well-developed. They vary in size, and larger species, greater than 1 meter, are not uncommon. Deep-sea demersal fish are usually long and narrow. Many are eels or shaped like eels. This may be because long bodies have long lateral lines. Lateral lines detect low-frequency sounds, and some demersal fishes have muscles that drum such sounds to attract mates. Smell is also important, as indicated by the rapidity with which demersal fish find traps baited with bait fish. The main diet of deep-sea demersal fish is invertebrates of the deep-sea benthos and carrion. Smell, touch and lateral line sensitivities seem to be the main sensory devices for locating these. Like coastal demersal fish, deep-sea demersal fish can be divided into benthic fish and benthopelagic fish, where the benthic fish are negatively buoyant and benthopelagic fish are neutrally buoyant. The availability of plankton for food diminishes rapidly with depth. At 1,000 meters, the biomass of plankton is typically about 1% of that at the surface, and at 5,000 meters about 0.01%. Given there is no sunlight, energy enters deep water zones as organic matter. There are three main ways this happens. Firstly, organic matter can move into the zone from the continental land mass, for example, through currents that carry the matter down rivers, then plume along the continental shelf and finally spill down the continental slope. Other matter enters as particulate matter raining down from the overhead water column in the form of marine snow, or as sinking overhead plant material such as eel grass, or as large particles, such as dead fish and whales sinking to the bottom. A third way energy can arrive is through fish, such as vertically migrating mesopelagic fishes that can enter into the demersal zone as they ascend and descend. The demersal fish and invertebrates consume organic matter that does arrive, break it down and recycle it. A consequence of these energy delivery mechanisms is that the abundance of demersal fish and invertebrates gradually decreases. The distance from continental shorelines increases. Although deep-water demersal fish species are not generally picky about what they eat, there is still some degree of specialization. For example, different fish have different mouth sizes, which determines the size of the prey they can handle. Some feed mostly on benthopelagic organisms. Others fed mostly on epifauna, or alternatively on infauna. Infauna feeders can have considerable sediment in the stomachs. Scavengers, such as snub-nosed eels and hagfish, also eat infauna as a secondary food source. Some feed on carrion. Cameras show that when a dead fish is placed on the bottom, vertebrate and invertebrate scavengers appear very quickly. If the fish is large, some scavengers burrow in and eat it from the inside out. Some fish, such as grenadiers, also appear and start feeding on the scavenging invertebrates and amphipods. Other specialization is based on depth distribution. Some of the more abundant upper continental slope fish species, such as cutthroat eel and longfin hake, mainly feed on epipelagic fish, but generally, the most abundant deep-water demersal fish species feed on invertebrates. At great depths, food scarcity and extreme pressure limits the ability of fish to survive. The deepest point of the ocean is about 11,000 meters. Bathypelagic fishes are not normally found below 3,000 meters. It may be that extreme pressures interfere with essential enzyme functions. The deepest living fish known, the strictly benthic abyss of Brotula galathii, eel-like and blind, feeds on benthic invertebrates. A living example was trawled from the bottom of the Puerto Rico Trench in 1970 from a depth of 8,370 meters. In 2008, a shoal of 17 Haddle snailfish, a species of deep-water snailfish, was filmed by a UK-Japan team using remote-operated landers at depths of 7.7 kilometers in the Japan Trench in the Pacific. The fish were 30 centimeters long, and were darting about, using vibration sensors on their nose to catch shrimps. The team also reported that the appearance of the fish, unlike that of most deep-sea fish, was surprisingly cute, and that they were surprised by how active the fish were at these depths. Demersal fisheries. Most demersal fish of commercial or recreational interest are coastal, confined to the upper 200 meters. Commercially important demersal food fish species include flatfish, such as flounder, sole, turbot, plaice, and halibut. Also important are cod, hake, redfish, haddock, bass, conches, sharks, rays, and chimeras. The following table shows the world capture production of some groups of demersal species in tons. Black sea bass inhabit U.S. coasts from Maine to near Florida and the eastern Gulf of Mexico, and are most abundant off the waters of New York. They are found in inshore waters and offshore in waters up to a depth of 130 meters. They spend most of their time close to the sea floor and are often congregated around bottom formations such as rocks, man-made reefs, wrecks, jetties, piers, and bridge pilings. Black sea bass are sought after recreational and commercial fish, and have been overfished. Grouper are often found around reefs. They have stout bodies and large mouths. They are not built for long-distance or fast swimming. They can be quite large, and lengths over a meter and weights up to 100 kilograms are not uncommon. They swallow prey rather than biting pieces off it. They do not have many teeth on the edges of the jaws, but they have heavy crushing tooth plates inside the pharynx. They lie in wait, rather than chasing in open water. They are found in areas of harder consolidated substrate, and use structural features such as ledges, rocks, and coral reefs as the habitat. Their mouth and gills form a powerful sucking system that sucks the prey in from a distance. They also use the mouth to dig into sand to form the shelters under big rocks, jetting it out through their gills. The gill muscles are so powerful that it is nearly impossible to pull them out of the cave if they feel attacked, and extend those muscles to lock themselves in. There is some research indicating that roving coral groupers sometimes cooperate with giant morays in hunting. Deepwater benthic fish are robust, muscular swimmers that actively cruise the bottom searching for prey. They often live around features, such as seamounts, which have strong currents. Commercial examples are the orange roughy and Patagonian toothfish, because these fish were once abundant, and because the robust bodies are good to eat. These fish have been commercially harvested. conservation status. Major demersal fishery species in the North Sea such as cod, plaice, monkfish and sole are listed by the ICES as outside safe biological limits. The true sole solea is sufficiently broadly distributed that it is not considered a threatened species. However, overfishing in Europe has produced severely diminished populations, with declining catches in many regions. For example, the Western English Channel and Irish sea sole fisheries face potential collapse according to data in the UK Biodiversity Action Plan. Sole, along with the other major bottom-feeding fish in the North Sea such as cod, monkfish, and plaice, is listed by the ICES as outside safe biological limits. Moreover, they are growing less quickly now and are rarely older than 6 years, although they can reach 40. World stocks of large predatory fish and large ground fish such as sole and flounder were estimated in 2003 to be only about 10% of pre-industrial levels. According to the World Wildlife Fund in 2006, of the 9 sole stocks, 7 are overfished, with the status of the remaining 2 unknown. Data is insufficient to assess the remaining stocks. However, landings for all stocks are at a near historical lows. World stocks of large predatory fish and large ground fish such as sole and flounder were estimated in 2003 to be only about 10% of pre-industrial levels, largely due to overfishing. Most overfishing is due to the extensive activities of the fishing industry. Current research indicates that the flounder population could be as low as 15 million due to heavy overfishing and industrial pollution along the Gulf of Mexico surrounding the coast of Texas. Seafood Watch have placed on the list of seafood that sustainability-minded consumers should avoid the following demersal fish: sturgeon, Chilean sea bass, cod, flounder, halibut, sole, grouper, monkfish, orange roughy, demersal shark, red snapper and tilapia.